I want to do one last example of exactness. And what I want to do is I want to solve the differential equation 3x squared y plus 6x, all that's times dx, plus the quantity x cubed plus 4y to the fifth dy equals 0. And I should mention two things. One is that this is what's called an exact form, or sometimes called differential form. It's where you have some function times dx plus another function times dy. So these dx and dy we treat as differentials. And what we're going to do is we're going to try and figure out whether or not this is exact. Okay, so the second thing I want to say is that, well, it's a reminder to figure out whether or not this is exact. We're going to take the part that's in front of dx and differentiate with respect to y. So 3x squared y plus 6x. If we differentiate with respect to y, we're going to get 3x squared. And we're going to take the part that's in front of the dy and differentiate with respect to x. So if we have x cubed plus 4y to the fifth, if we differentiate that with respect to x, we get 3x squared. Those two are equal. That tells us that this is exact. If this was not exact, then you just have to go back and manipulate it somehow and try something else. Maybe it's linear, maybe it's separable, who knows. But if it's not exact, then this method won't work. Ours is exact, so we'll continue on. So we know that this quantity, 3x squared y plus 6x, is going to be the partial derivative of f with respect to x, where f of xy equals c is our solution to the differential equation. So we know that f sub x is equal to this first part, 3x squared y plus 6x. And if we integrate both sides with respect to x, this tells us that f of xy is equal to x cubed y plus 3x squared plus g of y. And then we'll do the usual thing where now we're going to differentiate this version of f with respect to y, set that equal to the other version of the partial of f with respect to y. So if we differentiate with respect to y, we're going to end up with x cubed plus g prime of y. And then if we set that equal to the other expression, we know that that should be equal to x cubed plus 4y to the fifth. So this tells us that x cubed plus g prime of y is equal to x cubed plus 4y to the fifth. And then that implies that g prime of y is 4y to the fifth, and therefore that g of y is 2/3 y to the sixth. 4 over 6, yeah, y to the sixth plus c. And again, you don't really need the plus c as we saw before. And so it turns out that our solution to this differential equation that we started with is going to be this function f of xy, which was x cubed y plus 3x squared plus 2/3 y to the sixth equals c. Okay, and so that's going to be the solutions that we're going to have to this differential equation. Okay, they're all going to be in that family for various values of c.